All right, let's tread some new ground with this. We've seen one example of this five-step argument procedure in action, but it was really only verifying what we already knew. So let's take a look at some more examples. So the next guy in our PowerPoint slides goes as follows. Says, I study for 5 hours or I fail. I didn't fail, therefore I studied for 5 hours. Okay, so that's our format. Let's break this down symbolically and then see if the argument structure holds up. All right, so we need to identify simple statements before we can write out the argument. Turns out this time we're only going to need two. So first off, I studied for 5 hours. So Q, I failed. So those are the only real building blocks we need here. So now we can take a look at the structure. So H1, it says, I study or I fail. That's a disjunction. So I need P or Q for that first one. Hypothesis 2 says, I did not fail. So since I didn't include a not in here, that means I need a negation. Technically, if you wanted to, you could rework the argument and have not failing in here, but yeah, I think it's cleaner this way. All right, so now we've got our two hypotheses. Our conclusion says, therefore, I must have studied for 5 hours. So, therefore, P. All right, so that's what we're looking at. We've got our H1, we've got our H2, we've got our C. Now, jump cut. I kind of wish I could have afforded another board where I just like painted these lines in, but oh well. So we've got our setup here. P and Q, basic truth values set up. Let's break this sucker down. So H1 was a disjunction. Remember, a disjunction is true so long as we have at least one true in the components. That happens here. That happens here. That happens here. That does not happen here at the bottom. So, and again, if you had just copied the structure from the basic truth tables handout, I get it. So there's H1. H2 isn't just a straight copy and paste job like it was last time. We need the negation of our statement Q. So twiddle Q. So I take my true false values here and I flip flop them. So T becomes F, F becomes T, T becomes F, F becomes T. So H1, H2, down. What's up next? That's right, we form a conjunction with these two guys. And if we have a pair of trues, we get a true back. Any other combination gives us a false. So that's a false because we don't have two trues. Here we get a true. Here we get a false. Here we get a false. Okay, so there's our conjunction. All right, conclusion time. It's pretty short. It's just the statement P. So yeah, we can take this, we lift it, we plant it into that spot in the truth table. When you've been at this for a while and you sort of built up some muscle memory, you might be willing to risk just like labeling this column C. I don't recommend you do that until you've got a fair amount of practice with this. I mean, I actually still generally would write something like this out just to make sure I don't end up looking in the wrong place. So we've got everything we need. We've got our conjunction, we've got C, now we make the big conditional. H1 and H2 implies C. Remember, true implies false gives us a false. Any other setup is true. False implies true. That's not the one that I said is a false. True implies true. False implies false. And we got that guy again. So there we go. You can circle this guy up if you'd like, or just have me Vanna Whiting these values right here. We have all trues. That's what we're supposed to have if the argument is valid. So congratulations, we actually have done something new with this now. All right, so that's an example of this in action. Let's take a look at one more. The next example that shows up in the PowerPoint slides talks about a marketing plan and its impact on profits. So we have, if our marketing plan is successful, then our profits will increase. That's hypothesis 1. Hypothesis 2 says our profits have increased. The conclusion says, therefore, our marketing plan is successful. So let's break that down. So we have a statement P that talks about the success of the marketing plan. Again, I'm shorthanding this pretty aggressively just so you don't have to try to read a bunch of my handwriting on the board. Statement P, marketing plan has been successful, or is, again, verb tenses, whatever. So, statement Q, profits increase. Again, verb tense, bear with me. So, that's all we really need this time around. That's good news, right? So, now if we build this thing up, we have an if-then inside our first hypothesis. So, that's our clue for, that's right, a conditional. So we have P implies Q, kind of like we saw in the Isaac Newton example. Things change because now hypothesis 2 says profits have increased. So that's actually this guy right here. So we have a bit of a structural difference compared to the first example we looked at. In our conclusion, the punchline says, therefore, our marketing plan succeeded. So we have that as our punchline. Okay, so it feels really subtle. You might look at this and say, well, that looks an awful lot like what we did with Isaac Newton, and that one was valid. Let's dig in and take a look. We've got our truth table set up right here. P and Q, once again, taking their customary roles on the far left. So now we make our way through our process. H1, it's a conditional again. So if P, then Q. By now, I'm taking it for granted that, we just know that bit. Again, there's nothing wrong if you need to take a moment and walk through it, but we're just going to keep going. So that's H1. H2, well, that's another copy and paste job. I just grab the Q column, because H2 is just Q, and I transplant that stuff right here. All right, we got that. H1, H2, resolved. Now conjunction time. True and true is true. False and false, false. True and true, true. True and false, false. All right, we've got our conjunction. Conclusion is simply statement P. Again, it's a copy-paste job. We take the P column, write him in here. True, true. False, false. If you're super observant, you may notice something that gives the game away at this stage. If not, it's fine. All right. So now we've got the big conditional at the end. H1 and H2 implies C. You'll notice these argument structures, they pretty much all break down to that. So true implies true. That's fine. False implies true. Also fine. True implies false. That's the one where the conditional breaks down and is false. And then we have false implies false at the bottom. That is true. And again, you may have already noticed that in there. Again, the whole left-right thing. What are we looking for? We're looking for a column of all true results when we get to the end of this. Not so much here. If all we cared about instead of completing the truth table was, looking to determine validity, the instant I wrote down this F, we're done essentially. I don't do that, but you get the idea. So we have a false here. Since that does not always hold up, that means our argument is invalid. So this is one of what you might call sort of one of the classic logical blunders. It's happened often enough through the ages of time that it gets its own name. It's called the fallacy of the converse. So it happens, as you say, it happens painfully often. Funny story, if you dig around through episodes of the original Star Trek series, Mr. Spock actually makes this precise mistake somewhere, which is amusing given his, bent for unflinching logic and stuff. That's not going to be on the test. I just find it worthwhile to take a look at. So at this stage, we've taken a look at 3 examples of this stuff in action. So I want to take a look at a couple more. I'm getting a little more involved in the format, not quite so much direct copy and paste type content. So keep watching.